afternoon and welcome to Maths Mr. Harris. Lesson on reflection today. Sorry if you were here yesterday and were looking for this lesson yesterday, which is why it said Wednesday on the screen. It's because I had all sorts of problems. My internet just decided, no, not going to work today. I've decided I want a rest after it's been used too much. So it just packed in and my voice packed in and it just went, ah! So we had a bit of a panic yesterday, but it's all back to normal today. Normal. I'm not normal, but it's back at least. I'm going to be teaching you today about some reflection, hopefully at a GCSE level. So we're going to be looking at reflection on XY grids, and not just basic mirror patterns, but taking on what we already know and taking it a bit further. So hopefully, let's get ready to go. Yeah, so we're going to be talking about reflections today, and reflections are a way of manipulating shapes. So there are four: reflection, rotation, enlargement, and translation, which spells roulette. So we instead flip it all over and we add a Y. Why? Because I want to. So we've got Terry. Terry, transformation Terry, tells us it's translate, enlarge, reflect, rotate. We're going to be doing reflect today because we're doing the third one in the list. But we're going to start off with reflections and see how we get on with that. So, without further ado, don't know why we're doing anything. This should be on the screen right now. I have a horrible feeling it's not. That would be annoying, wouldn't it? It did appear eventually. So we're looking at all those different things, and we're going to be learning what reflection is and why we use it and how we can use mirror lines and how we can do it diagonally. Whizzy. So while we're just getting started, I do remind you that if you send me work, it doesn't have to be if you're in the live lesson. If you send me work on Facebook group or email, I will try and be doing answering questions. If you ask me questions, I'll try and encourage a gallery of different things. So just a quick reminder there. So what have we? Well, have a go. Copy those three shapes down and reflect them. Very quick warm up while I say good morning to Alicia, Amber, Vera, Hayden, Laginette, and Midnight Games XXXXXX. Hello to you all. It's wonderful to see you all here. It's amazing that there are 11 of you here and 4 of you already liked the video. That's brilliant. Thank you very much for doing that. So this is a very quick warm up. Hopefully the first two won't have caused you much grief. There's the first reflection. There's the second reflection. All we've just done is copied it across or copied it down. And the third one might confuse a few people, but if you turn your head 45 degrees, so when you're looking at the screen you go like that, you will then see the last one actually goes like that. And that is how you know that you've reflected it correctly, because it matches along that line. So what I'm going to be talking about is mirror lines. But we want to be using an XY grid. X goes along, Y goes up. So we're going to need to express our mirror lines as lines on here. So we don't just draw random lines. So the first thing we've got is the X-axis is the line going across. And X is a cross, so X goes across. And then the Y-axis is the one that goes down the middle. And many times we will need to do reflections where we say reflect in the X-axis or reflect in the Y-axis. If you're reflecting the X-axis, that is where you will draw your mirror line. You can go over it or make it slightly thicker or use a thicker pen to show the mirror line. But what about if we get a line like that? That line has gone through where X is 2. If we think about the coordinates that have those points, it would be 2, 1, 2, 2, 2, 3, 2, 4, but always 2 something. That's because this line is called X equals 2. So we would call this the mirror line X equals 2. That's going to be relevant for quite a lot of the stuff I'm going to be doing shortly. Then we have this line. This line cuts through where Y is 3. So this mirror line would be called Y equals 3. There's only one other we're going to consider right at the end, and we're not moving on to that yet. So I guess the best place for me to head is over to my whiteboard so I can talk you through a bit more of this. And here we go. Hopefully I'm here. Hopefully you've got everything you can see. I'm just going to check whether I think I'm not in the way. I might slightly be in the way. So let me just move this over so that I'm no longer in the way. What we're going to need to do, I'm going to use a nice purple for this. We're going to need a shape to start off with. And what is wrong with a nice trapezium? It would not be nicer if it was on the lines, but it's okay for now. I think if I circle that, it may even snap it. No, it doesn't. That's a shame. We'll leave it like that. So, this shape, we are going to use, first of all, we talked about the mirror line could be the y-axis. So I'm going to draw, and my mirror lines are always dotted. And I'm not going to do the whole y-axis, but that would be the y-axis. So to copy it across, you can use tracing paper, but I always think the easiest way to do it is, well, that's one square away, so we're going to go one square the other side, and this one's 2 squares away, so that's 2 squares the other side. And you'll notice we have been able to use the y-axis to reflect. This would be reflect in the y-axis. In green, I'm going to reflect in the x-axis. However, it doesn't treat it as like, oh, if it doesn't have the word then, which I'm going to get rid of, it doesn't have the word then, we don't reflect this shape. We call this the image. That's A. That's A dash, because it's the image. The image is after you've taken the object, which was our starting shape. We started with that, if you remember. The image is what happens after it. So our second image is reflecting in the y-axis. Here's the y-axis, so we're going to draw the mirror line. Always draw your mirror line on. It's 1 away, so we're going to put 1 away. I was 1 away. No need for singing, Mr. Harris. We've had words with yourself. And that would be the shape. Notice how every corner has to be the same distance away from the line as it was here. So this is 1, 2, 3, 4 from the line, so this one's got to be 4 from the line. This, again, I'm going to call it A dash dash because it's a new question, but you could call it B. Sometimes it will say call it B, label it B, so therefore we delete the A dash dash. We'll call it B, like it says in the question. That was quite straightforward. We're just using the x-axis and using the y-axis. Here's one I can then do, but using what we just covered a minute ago, we need a new shape first of all. So I like to sometimes use flags. Here's a nice flag. I'm even going to make it go below the line. Now, the question is going to say, reflect in the line x equals -1. And so here we've also got reflect in the line. So we've got 3 away. So we're 3 away here. And that way, because that's 4 away, 4 away. And you can always do the corners to help you get the right places. Always write the name of the line on there. It's because this is the x-axis, so x equals -1 goes from where x is -1, draw the mirror line and reflect it across. This was our object because it's where we started, so this would be our image. Object goes to image. The second question might have said reflect in the line y equals 2. Now this is quite interesting. I like it when these questions happen. If I draw the line y equals 2, that's in the middle of the shape. Actually, what happens is this point here moves to here. This point here swaps with it. This is already symmetrical. So the only thing that happens is it flips over on its own head. So you almost imagine sticking a pole in it. If you imagine sticking a spike through the flag and spinning the flag round that pole, that's what's going on here. The line can be inside the shape and it's causing this sort of rotation around the central pole, and that's how this is working, making sort of a propeller or spinner type system. So that's why when I go back here, you'll see I need to put the line y equals 2 on here. But when you have a mirror line that's in the shape already, the shape gets mapped on top of itself. Don't worry, I've got another example of this. I thought I had another example. Yeah, there is. I'd already gone too far. There we go. So, we sometimes will have, I'm going to start with a shape over here. This one, this one, this one. Another trapezium, but a different sort of trapezium. And I'm going to reflect in the shape. Not in the shape, Mr. Harris, in the line. We'll start off x equals 1. So here's x equals 1. And don't forget to label it. That's 2 away, so we're going 2 away. 3 away, so 3 away. 4 away, 4 away. So this one must be just off the thing. Wouldn't normally give you questions that are not fitting, but you can see that one. But I did say I'd give you another example of what happens when it's in the line itself. What about reflect in y equals 2? If I draw y equals 2 on this shape, you'll notice it's in the shape, so you imagine putting a skewer and spinning it round. That's going to go to there, there, there. It's going to rotate around the point, almost like it's a spinning wheel. It's got a spike gone in it and it's spinning around that central pipe, a bit like a propeller again. But one thing I forgot to do is I have to, if I'm writing the mirror line, write y equals 2. Now I'm going to remove this one, so hopefully it's a video so you can pause and go back to this at any point. But I wanted another copy of this thing, grid, so I wanted to be able to draw on it immediately. The final thing to talk about is what to do if it's diagonal. So in order to do a diagonal line, we need to know what the equation of those are. If you were listening to my primary one this morning, or maybe you've got a younger brother or sister, or maybe you're a primary school who's stayed on for the secondary one, you will know that that is y equals x. This is because it is 1, 1, 2, 2, 3, 3, 1, 1, 2, 2, 3, 3. This diagonal line is called y equals x. And it carries on all the way through, so I don't like to stop that, because it doesn't stop there. We call it y equals x. When you're doing diagonals, be very careful. I've seen people before draw this. That would be wrong. It is not down like that. Instead, turn your eyes, as I showed you before, so that the line almost becomes vertical to you. And you'll notice this is one diagonal from the line. So we're going to go one more diagonal. That is where that point has moved to. But this one's already on the line, so it stays on the line. That means that line goes to there. In fact, this is a reflection in the line at y equals x. A diagonal reflection. Okay, so hopefully this is something you can all makes sense to you and you can understand what's going on. I'm just suddenly panicking and just checking I have actually gone live and you can all see what's going on. This is the problem when you make mistakes like that. You then get paranoid for a few weeks. This is the diagonal reflection in that line y equals x. So we're constantly looking at how we can do the different ones. This one here, if you wanted to take it this far, is called y equals minus x. This is because the line here would be 1 minus 1, 2 minus 2, 3 minus 3, and the other way around. Minus 1, 1, minus 2, 2. They're all on that line. Therefore, it's called y equals minus x. The y is the minus version of x. Whatever the x is, y is the minus version of it. Then we would go, well, this is 1.5. So I go another 1.5. That's going to go to there. This is 2.5. So I'm going to go another 2.5 to there. This is where that one would go. And it's been reflected. If you turn your eyes, you can see that they are mapping each other. They do go together. So we have covered quite short succession, but we've covered exactly how we reflect in various lines. We've then just briefly looked at the diagonals, and we've just talked about the fact that the diagonals mean that you just have to either turn your head or make sure you're being very careful, because the shape will always turn 90 degrees clockwise or anti-clockwise, depending on which way you're using, which diagonal you're using. It causes like a 90-degree rotation. So it's important that you have an understanding that the shape should not be like just another one down there. It's got to have turned as well because of the nature of reflecting in a diagonal line. So just practice those ones as well. In the worksheet below, you will see that in the description below, there's worksheet on practicing multiplying and dividing is not what it is. It's reflection. I'm sure I changed that. Complete the reflections worksheet. I could be certain I changed that. And then the dotty picture taskmaster is what we're doing today. It is the best dotty picture things. Apologies, a wasp has just arrived to come and say hello to the live stream. So clearly fancies himself as a bit of a streamer or a beamer maybe. So I'm glad I'm not on screen right now because I'd be freaking out about a wasp. I'm going to keep talking and pretending it's not here. I might have to hit it with a clipboard or something in a minute. Try and get it out the room. My window's not open as wide as it could be. Hopefully it's not going to get me. So yeah, that's what we're doing. We're trying to get your dotty picture to me, and then there'll be another Taskmaster challenge for everyone next week. I'd love to see some really cool dotty pictures. I've already seen a couple, so they're looking really good. Yeah, get involved. If you want to ask me questions, you always can speak to me in the normal places, and like and subscribe if you've learned something. I hope this has been useful to you. I hope you can go away and practice it. I've been Mr. Harris. You've been awesome. Have a wonderful day.